Hi students, let's have a look over the mechanism of Friedel-Crafts reaction, student, in the very short way. Firstly, let us have a look over the reaction, student. This is the reaction benzene, student. This is the benzene, in which what I did, student, one hydrogen I have wrote in the expanded version. Now we are treating this benzene, which what, student, that is we are taking C2H5Cl, dear student, and catalyst we are having, student, anhydrous AlCl3. Right, students. Now what is happening here, student, this hydrogen is getting replaced in the form of HCl, student. So here is HCl is getting replaced, and what the product you are going to get here, dear student, this is the benzene is there, student, and here is C2H5 is there. This is nothing but, student, this is the ethyl benzene, dear student. This is ethyl benzene. Now, student, we are going to understand the mechanism of it. So when you talk about the mechanism, students, when you talk about mechanism, it involves into the 3 steps. Okay, now we are going to understand step number 1. Step number 1 is what, student? Formation of electrophile. Formation of electrophile, student. Okay, this is the electrophile. Dear student, how electrophile getting formed, student? Here we are having C2H5 and Cl. So C2H5 better you can write in the expanded version, student. Okay, in the condensed formula CH3, CH2 and Cl is there, right? And you are treating with what, student? That is AlCl3. AlCl3, this is the negative and this one is positive. So this total chloride is going on the aluminum to complete the octet. So what is forming, student? Here is CH3, this is CH2 positive, dear student, and here is what, AlCl4 negative. This is nothing but, student, that is positively charged carbon is electrophile. This is acting as a electrophile. Now, student, dear student, you go for the step number 2. Step number 2 means what, student? That is attack of electrophile. Here you can check it out, student. That is attack of electrophile. When you talk about the attack of electrophile, student, where it is going to attack, where the electron density is high, on benzene ring. It is going to attack on benzene ring, dear student. So let's have a look over it, students. Here you see this is the benzene, dear students. Here is this is the bond, and if you are having that is CH3, CH2, this is the positive charge, student. So how it is going to attack, dear student? This is going to attack on this position. So what is going to be formed, student? Here is this way, right? And here is this bond is getting used to form, that is CH2 and CH3, and here will be the hydrogen, and this is the positive charge, right? This is the positive charge. Now in the last step, step number 3, student, in the step number 3, what you are going to do, student? Removal of proton. Okay, you have to do, that is removal of proton. Okay, removal of proton. Dear students, if you talk about the removal of proton here, so this is the CH2 and this is CH3. Here is hydrogen is there, student. This is positive charge. So how the removal of proton it will taking place, student? Here you are having AlCl4 negative. This negative charge, student, will attack on this proton, and as a result of this, what is happening? This bond is going to be shift here. So if it is shifting, students, so what the product you are going to get? Here, students, here you see that is where is the bond is taking place. So bond are like that. This bond is double bond. Here is it is the CH2 and CH3, and here it will be AlCl3 plus HCl will form. This is what, student? That is what is ethyl benzene. This is what something known as, student, ethyl benzene. So this is what the mechanism of ethylation of benzene, student. Thank you so much for watching, friend. If you find this video helpful, please do like and subscribe the channel, and don't forget to comment, student. Please do comments, student. Please do comments.